Which of the following statements accurately describes the purpose of scikit-learn's setconfig? Function A. It sets the global configuration for scikit-learn by defining variables like default random state for random number generators. B. It configures the specific settings for a particular machine learning model, such as the number of estimators in a random forest. C. It manages the loading and saving of trained machine learning models to disk. D. It defines the type of data that scikit-learn can work with, such as numeric or categorical features. E. All of the above. True. The setconfig function in scikit-learn allows you to set global configurations, including the default random state for random number generators. This ensures consistency and reproducibility in your model training and execution. By specifying a default random state, you can control the randomness introduced in your model's training process, ensuring that if you rerun your experiment with the same data and the same random state, you will get the same results. This is essential for reproducibility in research and development. Global configuration. Setconfig allows you to establish default settings that apply across the entire scikit-learn workflow, including aspects like random number generation, data preprocessing, and model selection. True. While setconfig establishes global defaults, you can still customize the parameters of individual models using their respective constructors. For example, you can specify the number of estimators in a random forest by passing this parameter to the random forest classifier constructor. This allows you to fine-tune the model's behavior to your specific problem and dataset. You can even override the global configurations set by setconfig on a model-specific basis, giving you a granular level of control over your model's training and prediction. Model-specific configuration. While setconfig sets global defaults, you can still customize the specific parameters of individual models using their respective constructors. True. The setconfig function doesn't directly manage the loading and saving of trained models. This is handled by functions like joblib, dump and joblib, load. These functions allow you to save trained models to disk, making them persistent, and later load them back for reuse without retraining. This is crucial for sharing models, deploying them in production, and saving time by avoiding repeated training. Model persistence. Setconfig doesn't directly manage saving trained models. It's controlled by functions like joblib, dump and joblib, load. False. Scikit-learn is designed to handle diverse data types, including numeric and categorical features, without requiring explicit configuration through setconfig. Its flexibility allows it to handle both numerical and categorical data, as well as a combination of both. You can directly feed your data to scikit-learn algorithms, and the library will automatically detect and handle the different data types. Setconfig doesn't play a role in defining the type of data scikit-learn can process. Data types. Scikit-learn's flexibility allows it to handle diverse data types, including numeric and categorical features, without requiring explicit configuration through setconfig. True. As explained above, setconfig plays a central role in global configuration, including setting default random states, but also allows model-specific customization and doesn't directly handle model persistence. It allows you to control various aspects of the library, offering a powerful tool for configuring scikit-learn. None. E. All of the above. Global configuration. Global configurations in scikit-learn are settings that apply to the entire library, not just individual models. They are managed by functions like setconfig and control aspects like default random states, data preprocessing, and model selection. These configurations provide a consistent environment for your entire machine learning workflow. Imagine you are working on a machine learning project involving multiple models. You want to ensure that all models use the same default random state for reproducibility. Using setconfig, you can specify this default state, guaranteeing consistent results across your models. Model persistence. Model persistence is the process of saving trained machine learning models to disk for later use. In sklearn, this is done using functions like joblib, dump and joblib, load. Saving models allows you to reuse them without retraining, facilitating deployment, sharing, and time savings. Consider a scenario where you've trained a complex model for image classification. To deploy this model in a production environment, you would need to save it to disk. Using joblib, dump, you can persist the trained model, allowing it to be loaded and used for predictions on new images. Random state. A random state is an integer value used to initialize random number generators in machine learning algorithms. It ensures reproducibility by controlling the randomness introduced in the training process. Using the same random state with the same data guarantees identical results when you rerun your experiment. Let's say you are training a model for predicting customer churn. To ensure your results are reproducible, you set a specific random state using setconfig. Now, whenever you train the model with the same data and the same random state, you'll get the same model, ensuring consistency and confidence in your findings. Model selection. Model selection involves choosing the most appropriate machine learning model for a given task. It involves considering various factors like data characteristics, the desired outcome, and model performance. Setconfig can influence model selection by setting default hyperparameter values for various models, influencing the model's behavior and affecting its performance. In a scenario where you need to predict housing prices, you might consider using a linear regression or a support vector machine (SVM). Setconfig can help by setting default hyperparameter values for these models, potentially influencing their performance and making it easier to compare them for your specific problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 42. Consider a dataset with 3 data points, each with 3 features. When training a model, we introduce randomness, especially when splitting data into training and testing sets. Setting random state 42 ensures that the data is split in the same way every time, guaranteeing reproducible results. If you were to train a model with the same data but without a fixed random state, the splitting would be random, resulting in different models and predictions. This inconsistency makes it difficult to compare results or trust your findings.